This week on Science Break, the HAC 2100A Laboratory Turbidimeter. Turbidity is the measure of the murkiness of a liquid, which is caused by suspended solids. The 2100A measures turbidity by shooting a beam of light through the sample and detecting the amount of light reaching the sensor. This is directly proportionate to the amount of light scattered and absorbed by the suspended particles in the sample. The 2100A is designed for benchtop operation and should be placed in a location free of direct sunlight, vibration, and dust. This ensures the most accurate readings possible. Plug your machine into a grounded 3-prong outlet.
Remember to always use caution when dealing with electricity.
The 2100A turbidimeter has only 2 operational controls, a power and range selector switch and a standardization control. Turn on your turbidity and set the range to 1000 NTU by rotating the left dial. Let the machine warm for 30 minutes to allow a photomultiplier detector to stabilize. In the meantime, you can prepare your samples for testing. To prepare the sample, rinse the sample cell 3 times of the sample to be used. This is done to ensure no contamination from residue occurs. Next, fill the cell with approximately 25 milliliters of test sample. Make sure to clean and dry the outside of the cell with provided Kimtech delicate task wipers. This is most important for the bottom of the cell. It is also important to ensure there are no air bubbles or large particles in the liquid and no scratches on the cell, because all of these can affect the quality of the readings. It is not unusual for turbidity readings to vary plus or minus 5% when a cell is rotated because of the variations in individual sample cells. Clarity and cleanliness of a sample will make for the most accurate readings. This is of most importance when dealing with low turbidity. To take an accurate reading, position your eyes above the meter scale so the reflection of the meter needle in the mirrored strip cannot be seen. Before each series of measurements, the instrument should be standardized on the range setting that will be used for analysis. This is done by inserting the secondary sample that corresponds to the range you wish to measure. Place it into the sample compartment and close the lid. Now adjust the standardized control until the meter reading equals the value of the standard. Standardization is done to ensure accurate results. The photomultiplier tube detectors are extremely sensitive and are subject to output drift due to day-to-day handling. The standardization control allows for adjustments to accommodate this natural drift. Now that the turbidimeter has been standardized and your samples have been created, it is time to take a reading. Insert your prepared sample, being careful not to touch the sides or bottom. Now close your light shield and record the reading from the meter scale. When samples of a high turbidity are measured, it may be necessary to dilute the sample to bring it within range of the instrument. It is important that a finely filtered portion of the sample is used for dilution instead of distilled or demineralized water. This is because distilled or demineralized water may dissolve some of the suspended solids, altering the turbidity. After diluting your sample, always remember to multiply the reading by the dilution factor. When measuring on the 100 and 1000 NTU ranges, insert the cell riser provided in the accessories compartment. This is to reduce the distance between the bottom of the cell and the detector window. If the top of the cell extends beyond the sample compartment, use the extension tube provided in the accessories compartment. Use the foam-tipped cell riser retriever to remove the riser from the sample compartment when it is no longer needed for use. Then return all equipment to the accessory compartment. Congratulations, you are now ready to measure the turbidity of a sample using the HAC 2100A laboratory turbidimeter. Thanks for joining us today on Science Break.
Tune in next week for our tutorial on time travel using a flux capacitor.
Science Break.